everyone. In this video, I want to talk about what is the new Azure Route Server that is currently in preview. Before I get going, as always, if this is useful, a like, subscribe, comment, and share really is appreciated, helps the channel grow, and hit that bell icon to get notified of new content. Now, if you think about what is Azure Route Server doing, we kind of take a step back. I can think about we have a virtual network. And really everything that powers a virtual network is all routing. It's about knowing, well, where do I go to get to certain different destinations? If I want to maybe inspect traffic, well, I need to direct traffic to go to this kind of appliance to get checked before it goes to that destination. So everything is routing. And there are certain automatic routes. For example, if I think about a virtual network, so I have this great big virtual network in my environment. And remember, within this virtual network, that VNet is defined as one or more kind of CIDR ranges. Maybe it's a 10.000/8 is one giant CIDR range, or it could be multiple ranges in there. And I break that up. So I break that up into a number of subnets, which are a subset of the virtual network CIDR range. Now, the first 3 usable IP addresses are always taken by Azure, but essentially the first one, i.e. the .1, or whatever the first available is taken by the Azure's own default gateway, that software-defined gateway, kind of the fabric gateway. So I can think about, hey, I have kind of sub 1, sub 2, and into that subnet, we add network interfaces that consume that connectivity. Now, there are certain default routes. For example, I could think about, there's a route table. There's a route table for the VNet, but then there's more specific for actual individual subnets that get injected into the network interface cards that live in there. But I could think about, well, there's probably a 0000 default route, and its target is the internet. Now remember, this is all software-defined networking. It's not like a traditional physical network where, hey, the next hop has to be something physically connected to my subnet. My next hop can be something in different subnets. These are special types of object understood by the Azure software-defined networking. Now, I can add additional routes. I could think about, hey, look, I have another VNet over here. And this is CIDR range 2. They don't overlap, and I peer them. Well, when I do that, basically now there's going to be a new route added. It's going to say, oh, hey, to get to CIDR 2, i.e. that's my target, well, I have to go through, for example, hey, I'm using peering for this. So, hey, I'm using kind of peering. I might add things like service endpoints. So I might add a service endpoint for storage, for example. And I add that to this particular subnet. So when I add the service endpoint, well, it's going to have a whole bunch of entries that represent storage. The storage service in Azure, i.e. all of them or particular regions, have a whole bunch of different CIDR ranges. So essentially for all those IP ranges, I'm just going to write storage. It would know, oh, okay, well for these, I need to use this kind of service endpoint type of capability. And we can actually see this. So if we actually go and look, I can't do service endpoint. If I go and look at a network adapter, you can actually go, so I'll step back. So I'm looking at a virtual machine. I'm going and looking at its networking on that virtual machine over here. Then I'm selecting the network interface card, which I can kind of see here. So it's just a network interface. When I select that, if I scroll down, I have this effective routes. And if I select effective routes, it's going to show me what are the routes this network interface card is seeing, what's being basically injected into it to control how the virtual switch in the host that's hosting it will go and direct traffic. And here we can see things. Well, it knows, well, the address space of the virtual network. The next hop is just within the virtual network. It has things like that default route. Well, it knows that's the internet. That's handled through various different kind of snap mechanisms, depending on if it's part of a load balancer that has an exterior public IP, if it has an instance level, but that will get handled. Then I can think about, hey, virtual network service endpoints. They are service endpoints. So you see all these different IP addresses, 52 more, that represent different types of service that I have added into the subnet where this NIC belongs. And then we can see, hey, VNet global peering. So we can see those as well. And an interface endpoint is just a private endpoint. That's still within kind of the IP space of the particular subnet. So we can see we have these different types of route that get basically told so that they're modified. So hey, so the storage, so we have the peering, we have the virtual network service endpoint. I could try and be virtual network service endpoints. So they just kind of happen. They're kind of built into the service. But then we might add other types for different types of service. For example, I could think about, well, hey, I have ExpressRoute gateway. Now that ExpressRoute gateway, remember what that does, that's using private peering. So that private peering through kind of a meet me is then connecting to some on-premises location. And that on-premises location has a certain CIDR range. So that is kind of, let's say, CIDR 3, 192.168, whatever that is. Well, so now that's a new type of route that's actually going to get added. So now the route table would say, hey, to get to kind of CIDR 3, well, that's a virtual network gateway. And there'll actually be 2 entries. The virtual network gateway is highly available, active. There'll be 2 IPs, there'll be 2 entries that represent that. But now it knows, hey, to get to this IP space, I go via this gateway. That's my next hop. And the way this is working is BGP, Border Gateway Protocol. And I can think about, they are exchanging. So the ExpressRoute gateway tells the on-premises, these are all the IP spaces I can see. And this is telling the gateway, hey, these are the IP spaces I represent, so it can populate those route tables. So BGP is kind of our friend. And I think to be really accurate, it's eBGP, because these are BGPs between autonomous systems. These represent a different network. Site-to-site VPN is essentially the same thing. So if I had a site-to-site VPN, well, what is a site-to-site VPN doing if I'm doing kind of dynamic routing? Well, that is over the internet connecting to some location over here. So I'd say, hey, CIDR 4 is also a network gateway, and it's a different IP address for that site-to-site VPN. So we're adding these things in. Great. Understand how we're getting those. But sometimes I'm not using just the ExpressRoute gateway. I'm not using site-to-site VPN. Maybe I'm using an SD-WAN or a different gateway solution. So I have these kind of virtual appliances. So I can think about, hey, I add in some kind of network virtual appliance. Now they can be doing different things. So NVA2. They may be going and connecting to some IP range. Maybe I'm kind of some IP range CIDR 5. They also might be, hey, the next hop, because I want to go to the internet. There's 0000/0. I want that to be my default route. It's some kind of security appliance. And the way we have to do this today is typically we put a load balancer. I just did a video about this. So I do a load balancer that kind of represents them so it can health probe, check they're there. And I add something called a user-defined route. So I have to say, hey, look, well, this has a certain IP address. So I would have to go and manually create a route table and then link it into the subnets that want to use it. So I'd create a route table and I would say, hey, to get to CIDR 5, you're going to a virtual appliance and it's that FEIP1. But realize, well, if this IP address changes, and it's going to update the routing table. because now I need to know, well, there's a different IP space it goes to. So there's some kind of work involved in that. And it starts to get kind of painful after a while, having to maintain and create these route tables and link them to subnets for this to actually take effect. But that's how we would do it today. We would go and add those things. Okay, so now we have Azure Route Server. So what is Azure Route Server doing? So I can really think it's a conduit into kind of the route table of the virtual network. And more specifically, it can go and inject routes into the network interface cards of all the VMs in my kind of IP space and those connected networks. So I could have various network virtual appliances that could be gateways, they could be SD-WANs, they could be security appliances, firewalls. And now instead of me having to manually go and create route tables and say, hey, the next hop for this range is this appliance, it doesn't do that anymore. I don't have to create the route table or link it. The same way ExpressRoute gateways and site-side VPNs go and update the route table because it learns what IP spaces are here. Well, those NVAs know what IP space it represents. And through Route Server, it's going to let the NVAs talk to the Azure Route Server, which will then go and update the route table for me. So I don't have to manually go and create those route tables anymore. That's the whole point about it. Now, the way this is going to work is Azure Route Server has its own subnet. So I'm going to pick a certain subnet, and it's called Route Server Subnet. So it has to be that name, and it has to be at least a /27. So if I went and looked at my network right now, for example, and I quickly jump home, look at my virtual network, my subnets, you can see at the bottom here, I created a route server subnet. So it has to be called that, and it has to be at least a /27. It could be bigger, but it doesn't have to be. I just need to be a /27. That's what I require. And what this is going to let me do fundamentally is it's going to go and deploy this managed service for me that's behaving in a lot of ways like an ExpressRoute gateway. So into here, it's going to create this Azure Route Server service. Now, behind the scenes, what's actually happening, it's creating a VM scale set. So it's going to create, by default, 2 virtual machines. So remember, it's going to use the first 2 available IPs in that subnet. Remember, I lose the first 3. .1 is the gateway, .2 and .3 are for DNS. So there's going to be a kind of .4 and .5. And what we can now do, and this is the super cool part, for each of my NVAs, I can create a BGP peer. So hey, from this NVA, I peer to here for this one. And what I'm going to do quickly is I'm just going to erase this. Because as we're going to see, I don't actually need that anymore. I might still use it, but I don't have to have it necessarily. And this one is going to create a BGP peer with that one. And then obviously I want these to be redundant. So that will go there and there. So these are now BGP peers. So it's going to establish BGP sessions over those peers. So through those, they're exchanging information. So I really can think about now, hey, the NVAs, they know what they're connected to. They know what they represent. Either, hey, yeah, it's CIDR 5. And so now it will actually go and say, hey, look, I am CIDR 5. It will tell it via BGP. Azure Route Server, well, it will now go and inject that into the route table. So instead of me manually creating that UDR, I don't have to do that anymore. Instead, hey, it's just going to add, hey, CIDR 5 is kind of this virtual network gateway, and these have IP addresses. So it's, hey, NVA1 IP, and it will actually add 2 entries, NVA2 IP, if it's an active-active configuration. That's kind of a key point, what we're actually going to do here. So it's just updating the route table. If this IP range changed, if new spaces were added up here, the NVAs would know. through the BGP session they've established, it would tell Azure Route Server, which would go and update the route table and inject those into all of the VMs in these connected IP spaces, including the peers. So if I have peering to other VNets, it's going to handle those as well. So now it is updating that for me. Now, when I create these peers, we use, essentially this represents a different autonomous network service. So that I have different ASN. Azure is always 65515. Always. That's the same as the ExpressRoute gateway, the same as a VPN gateway. We are always 65515. That's always the case. So these would be something else. There are certain ASNs you can't use. They're reserved by Azure. They're reserved by the IANA. They are documented. If we go and look at the route server FAQ, it will actually tell you what they are. So what ASN numbers can I use in the NVAs? So it's telling me the ones that are reserved. So these are the ones I cannot use. And you'll notice 65515 is one of them because that is route server itself. That is ExpressRoute gateway itself. That is the Azure virtual network. So it's always going to be a 16-bit, doesn't support 32-bit ASNs, but essentially I can use anything outside of those. If I have NVAs that are connecting to the same IP space, the same network, they would use the same ASN because they're connecting to the same essential network at that point. Okay, so it deploys at least 2. If the region I'm deploying to supports availability zones, it will distribute them over availability zones so they are resilient. But realize, this is all about exchanging routes. It is not about data flowing. This is not a Azure firewall. It is not a gateway device. The actual packets of data are not flowing through Azure Route Server. Its only job is to establish these BGP sessions so it can learn about routes and, hey, tell the NVAs about the routes it knows about and tell this network about the routes the NVAs know about. That's all it's doing. So there is no data flow through this. It is only routes, which means it's fairly low CPU. It's fairly low powered. It's not having to do a whole bunch of stuff. Now, it's still important it's resilient because realize what it's doing is this route server information it gives, well, it would age out. If this was offline, all of these routes it's injected as part of these BGP sessions will age out and go away, which will then break all the routing. So I still need this to be resilient, but it's not really doing a whole lot in terms of computational power. So route server, hey, I'm here, I'm swapping around routes. So it's only doing that, it's not actually doing data traffic as well. Now, one thing I will point out, I'm drawing the NVAs in the same VNet as the route server. Technically, I can have a dual homed network. So the documentation actually walks through this. The idea here is, well, I can have this scenario. I could have peering, and I can establish BGP peers to NVAs in other virtual networks. I could even extend this to have ExpressRoute gateways in other peered networks. And that scenario is actually pretty interesting because if you think about the idea, ordinarily I can only have one ExpressRoute gateway. Well, imagine I wanted resiliency. I wanted the ability to have multiple ExpressRoute gateways used by one network. Ordinarily, I cannot do that. Well, actually now I could, because I could have different networks, an ExpressRoute gateway in each of them. By exchanging the routes with Azure Route Server and using an NVA, it can now inject the routes into my virtual network. So I now know about, hey, 2 different ExpressRoute gateways and the networks they connect to. So I can actually now use 2 different gateways, something that ordinarily is just something I can't do. So that's actually a super cool thing I can have. Okay, so let's go back to this for a second. I deleted the load balancer between the NVAs. Now remember, why did we have a load balancer? Again, go and look at my video about highly available NVAs to understand why that is. But essentially it's because we can't move IP addresses. And the load balancer does the health probing, checks it's there. Well, with Route Server, it can know about both of them. It injects two routes. And what will actually happen is, for me as something using it, I will use something called equal cost multipathing. i.e., if I see there's two equal paths in terms of length going to the same place, through this algorithm, it will basically distribute among them. The other thing a load balancer does, it would detect health. It has a health probe to find out if one of them is unavailable and remove it. Well, likewise, through the BGP, if one of them goes down, it will learn it's not available, it will remove its routes. So this is kind of a BGP convergence. So I can think about, hey, if there's a problem, you kind of get this BGP session failover. Now, here's the thing. This could take kind of up to 3 minutes, whereas the load balancer and its health probes could be tuned to be a far quicker failover than that. So that what this means is you may still want the load balancer. So the load balancer may be required if I want a convergence quicker than what BGP will give me. So there may be times, hey, I still want the load balancer actually in their picture. What we see very commonly today is these in kind of an active-active for SD-WAN scenarios. And there you don't have the load balancer. This is a very common pattern today. So I think that's one of the key use cases today where it goes and hooks into the route server and actually leverages this. Now it is super important to understand it is all about the routes. It's all about what the NVAs are telling route server the address space it represents. So if in the case I am an SD-WAN or a gateway, well, I'm going to have this kind of very specific CIDR range. So hey, I'm a gateway. Let's change my color. If I'm a gateway, if I'm part of an SD-WAN, it's going to look like this. And I'm probably going to have kind of this active type scenario. Now imagine it's not a gateway. Now imagine those NVAs are firewalls. And I want everything to go through it. I want all traffic in the network to come through me so I can check it. Well, then what you would find, those NVAs would be telling Azure Route Server what route? Well, the route it's going to tell it is 0000/0 to go to me. So then that would go to kind of the NVA. It's telling it, I want everything. Now typically, so this is more of a firewall scenario. And generally they kind of seem to run in active passive is very common because they are stateful. And today, again, without a load balancer, without types of SNAT, it can be difficult to do those. So it's very common to see that in kind of an active passive through this pattern. There's a danger here though. So what do we have? We have these telling it routes. We have ExpressRoute Gateway connected to on-prem. ExpressRoute Gateway will tell the on-prem the routes it knows. Well, actually it doesn't by default. So by default, although Azure Route Server actually does connect to ExpressRoute Gateway, it doesn't actually exchange routes in a branch-to-branch scenario. So for example, these NVAs essentially are classed as it's talking to something else. It's representing another address space. So by default, it will not go and program exchange routes with the ExpressRoute Gateway. Because think of that firewall scenario. Think about the scenario where this is 0000/0. If we went and exchanged that route through ExpressRoute to on-premises, now on-premises would say, hey, my default route are these NVAs. So any packets from on-prem would be sent up through ExpressRoute Gateway to Azure to go through this firewall. Now, maybe you want that. There are patterns where security is moving to the cloud. I do want it to go to Azure. And if that's the case, fantastic. I want to enable that setting. I want it to actually go through. So I want these routes to be told to ExpressRoute Gateway and vice versa. And I can do that. So basically I can enable a flag that is essentially branch-to-branch routing. So if I actually go and look over here at my route server for a second, so I've deployed one. And what you can see is it shows you the peer IPs. So this is actually those two IPs it created in its own little virtual subnet, because I have to know those, because those will actually be the BG peers of the NVAs. There's actually a configuration flag to enable branch to branch. So if I hit that button, then it will start actually propagating the routes it learns between the different NVAs to kind of each other for ExpressRoute. So again, if I want that to happen, I can set that flag, and then it's going to share those various routes. So that will enable that. That actually does something else as well. Imagine I have an ExpressRoute gateway and I have a site-to-site VPN. If I turn this flag on, i.e. share branch to branch, well, it will now basically tell this CIDR range to get to this CIDR range, hey, I'm your next hop. So it will enable branch to branch communications without having to add anything else, because these gateways will act as the next hop. Now, if it was other NVAs, they'd have to do something to forward the packets on. You'd need some kind of data transit as well. But for this scenario, if I turn on this branch to branch, I can now actually have routing between my branches over ExpressRoute to site-to-site VPN, something normally only vWAN does, the Azure Virtual WAN. So I can actually turn that capability on. The other thing, I mean, this does work with peering. It learns the IP space of peering. And I can even do this in the idea where I actually have multiple NVAs spread over different virtual networks. So I can think about a scenario where, hey, imagine maybe I had multiple hubs. So I had kind of this big hub 1, and then I had kind of a hub 2, and I have NVAs that connect them. So maybe they're peered, but again, remember, if I think about I have kind of various spokes connected to here, they're normally not transitive. So peering is not transitive. So if these are peered and this is peered, these can't talk to each other. But maybe I have some kind of NVA here, could be active-active, it doesn't really matter. Well, those NVAs are using BGP, so they learn about all the address spaces of all the connected networks and everything else. Well, guess what? If I add in Azure Route Server on each of these, and then these establish BGP here, what have I done? It's now going to populate all of the routes on all of the NICs in all of these connected networks. So now it will just work. I won't have to do a bunch of UDRs to say, hey, go to this NVA to get to these IP spaces. These routes it learns, it's going to propagate everywhere. So you can see there's some pretty cool patterns I can actually do when I start adding in the Azure Route Server. Because again, normally this would not work. We're adding a whole bunch of UDRs to tell it, hey, go to here for the next hops, this IP space and this IP space, etc. Normally the NVAs are intelligent. They're going to summarize the different IP spaces it sees. But this is fundamentally Azure Route Server. It's the ability to have this appliance that participates in BGP. Without this, there's no way to do this for my NVAs. It's all UDRs. Now, my NVAs can actually go and plug in and work with the routes for my virtual network and its peered virtual networks. That is what this is doing. Again, remember, data is not flowing through the route server. It's only doing the route exchanges, the BGP sessions, to enable that sharing of routes. So that's what it is. Couple of notes. Today, it does not work with Azure Firewall because Azure Firewall does not support BGP. This talks BGP. Today also, do you remember I talked about the idea, well, I might have an internal load balancer in front of the NVAs. Today, the NVAs cannot go and tell the Azure Route Server, hey, I represent this IP space, but your next hop is a load balancer. It can only tell it itself. So today, this doesn't work with that kind of load balancer scenario. I'm sure that will change in time, and I'll pin a kind of comment below when things change, because again, this is preview. But it's important to know those kind of two things. Each route server supports 8 BGP peers. Each BGP peer can advertise 200 routes, and it supports updating 6,000 VMs, so injecting those routes into up to 6,000 VMs. So pretty large in scope. If you want to play around with this, there are example ARM templates. For example, if you go and look actually in the documentation, it has an ARM template where it's using this Quasar, I think it's a little Linux NVA where you can mess around with the routes. You could even use Windows Server. Windows Server could actually be the network virtual appliance to work with this. So if you want to go and get started, and obviously there are real NVAs out there that are using this right now, and they will have their guidance on the overall configuration. But that's Route Server. I really hope this was useful, and good luck.